Welcome back. In the last lesson, we just handled the observer pattern that we are currently using when interfacing with the Firestore library in our application. But I did mention that there's a very high likelihood that in a future project that you join, you might not be using either the observable/observer pattern, or you might have your own server of some kind that is not Firebase. If that were the case, you may not use this observer pattern that we've implemented here. Instead, you'll use a promise-based pattern. And I just want to quickly go over how we would do that, but still leveraging our Firebase, Firestore database. We're just going to treat it like some regular API endpoint that we can make requests to or make API calls to because Firebase allows us to do so. There's actually two ways we can do this. The first way is we still leverage the Firestore collection ref objects that we get back from the Firestore library, except instead of returning this observable style of object, we return promises. I'm going to show you that way, and then I'll show you the other way where we use the native fetch. In order for us to still use our collection ref to do so, except doing it in a promise-oriented manner, instead of using onSnapshot, what we use is .get. What .get does for us is it makes a API call to fetch back the data associated to this collection ref, which will be the exact same as the snapshot object that we're getting back from our backend. The only difference is that instead now we call .then, and we pass our snapshot transformation into this .then. And if we save and go back, we'll see that our application behaves the exact same way, and our shop is still getting updated with the correct items from our Firestore backend. So that's a very simple way to just switch over to using a promise style if you're more comfortable with it. The only caveat here is that the only time we'll ever get new data from our backend is when we remount our shop. This is because we're no longer leveraging the live update stream style that the observable pattern lended us when we were using onSnapshot as before. Now we're literally doing one-off API calls inside of our component did mount, leveraging the promise chain style of doing asynchronous event handling. Now, how would we do this if instead we were to try this using the fetch pattern that might be more common if you were using any other type of database? Well, Firebase actually allows us to use their database, their Firestore databases, as APIs, which are accessible by a URL. And if we go to the docs here, we actually see that all of the URLs are nested under this base URL. The only thing that we have to do is we need to add and switch out this your project's ID with our database ID, which in my case, you can always find it if you go to your Firebase console inside of your project that you're using, you hit the gear, you go to project settings, and you'll find whatever your project ID is here. Now for me, it's CrownDB. So what you're going to do is you're going to take this ID and you're going to replace the section of this URL where it says your project document ID. So just replace that with your ID. And then what you want to do is you're going to copy this string up until the documents /section. So we want everything up until the cities LA portion of the URL. You're going to copy that. You're going to go back to your application and you're going to comment out this code. And then what you're going to do is you're going to just use the native fetch API as we remember. And we're going to paste our string in. And then we're going to get our collections. So we want to go documents / and then we just want to say collections. And we want the whole collections collection. And now we're just going to chain our .then. And as you remember from fetch, we have to convert our response to JSON. And let's just log out what our collections looks like so we have an idea of what it is that this endpoint actually gives us back. Because we're not dealing with snapshot or reference objects anymore. Now if we look inside of our actual console log, we'll see we get an object that has this documents array on it. Inside of this array, we have these objects that represent the collection documents that we have inside. However, the fields are actually on this fields property, and the fields have the actual name of the field, but not the value. The value is actually in another property, and here we say it's called array value. And then on the array value, we see it's a values. And even in the values, we see that they're map values that goes to the fields that finally give us the actual objects that we need. Now, this is extremely nested. This is at least 8 levels nested just for us to get these values. So we're not actually going to use them. Not for this case at least. But we did see how we can use fetch to get at least the objects that we need. If we had to interface with such a nested object like this, we would just modify our actual modification function so that it properly navigates through that and then builds us out the object we need. But the pattern would largely remain the same as pretty much what we have here, right? In this final dot then, we would still just convert the collections array into the collections map object we need, fire our update collections, and then set the state. So hopefully you've seen at the very least how simple it is, based on the pattern that we've already written, to pretty much just convert what was already before our observer pattern into this promise pattern. Very simple, very easy. It's just that with this final fetch method and Firestore in particular, it's just such an unnecessary amount of work for us to do right now, especially when we have a working solution. So let's actually remove this fetch from our code base and just go back to using our collectionref.get method. Because here we're going to actually segue into a lesson on Redux asynchronous event handling. So right now, what we're doing is we're handling the asynchronous nature of fetching data inside of this component. Our shop component is the one that actually does the call to get and then to update the snapshot and all of this information here. But technically speaking, it does not have to be the actual location that gets this information or actually handles the logic regarding the fetching of this information. Instead, what we might want to do is have this code inside of a Redux action that will handle all of the asynchronous nature and then fire the event, because that's really all we're doing here. But in order for us to do that, we need to understand the reasons why. Why would we want to move the logic out of our componented mount? The only reason why we would ever want to do such a thing is because there's a chance that we need to do this call where we're fetching some kind of data from our backend and then converting it and storing it in our reducer somewhere else in our application. What do I mean by this? If we never go to this page, this shop page at all, right? Let's say we refresh our application. We will actually see that we have never fired our set categories or set shop collections, right? Our collections is always null. Our action only fires when our shop component mounts for the first time, either if we go to the /shop route or /shop category ID, /hats, /jackets, whatever. There's a chance that there's another component that we want to leverage this exact same method. We don't want to have to rewrite this exact same code in another page component because it needs to access the shop component. And we also don't want to move everything up into our top level app.js component because then we might be rendering so much data in our application once our initial application mounts that it seems really tedious. We just want to reuse this piece of the code, if you understand what I'm saying. If we were to move this ability to fetch from the database and store it into our reducer into the top level, such as into our app component, which is our highest level component that we know always mounts if our application loads, then imagine if we had 5, 6 data endpoints that we needed to do the exact same pattern for, right? Let's say we had to do it for multiple documents and multiple collections. Well, we would be fetching and waiting and rendering a lot of data the moment the application mounts, and that's really bad on performance. What we instead want to do is keep this pattern where we kept it on the appropriate page, which is our shop page, that cares about the data. It's just that there's a chance that there's more parts of our application that might also need to leverage this collection, and should not be dependent on our shop page mounting for them to get the collection data that they need. So what we're going to do, as I mentioned earlier, is move this into an asynchronous Redux action that will allow us to reuse this in multiple places. But we are going to tackle that in the next lesson. But now is also probably a good time for us to commit our code. So let's just check what we've added. And we've added a lot. So we are going to git add all this code that we have. So let's just say what we did was implement code that pulls in our shop data from Firestore and stores it into the shop reducer from our shop page. Also included are with spinner HOC. And now let's push this up and move on to the next lesson.